Our next section of sets is section 2-3. It is talking about Venn diagrams and set operations. So in section 2-3, we will learn how to create Venn diagrams. A Venn diagram is a useful technique for illustrating set relationships. The name for John Venn invented and used them to illustrate ideas in this text on symbolic logic. We start out a discussion using a rectangle, usually representing the universal set U. The items inside the rectangle may be divided into subsets of U and are represented by circles. The circle in this case is labeled A and represents set A. So two sets which have no elements in common are said to be disjoint. That is, the intersection of the disjoint set is the empty set. That is, there are no common elements in the two sets since they do not overlap in area between the two circles. In this particular case, you can see from the figure we have set A and set B. They do not overlap each other, and in fact this is what we call disjointed. If set A is a proper subset of B, then A is a proper subset of B. The circle A is completely inside circle B. If A contains exactly the same elements as set B, then A equals B, and both sets are drawn as one circle. Two sets, A and B, with some elements in common are generally overlapping. Here you see in this diagram we have set A that overlaps some of the elements in set B. When set A and B are disjointed, they have no elements in common, and region 2, which is overlapping in our picture, is empty. When A is a subset of B, every element of set A is also an element of set B, then region 1 is empty and region 2 is completed. If B is a subset of A, however, then region 3 is empty and region 2 is full. So in the case when A equals set B, all of the elements of set A are elements of set B, and all the elements of set B are elements of set A, so there are no regions 1 and 3, it's all just one big circle, region 2. So in general, when sets A and B have elements in common, those elements are in region 2. Elements that belong to set A but are not in set B are in region 1. Elements that belong to set B but not in set A are in region 3. If no elements are in A or B, they're in region 4. So therefore, if I have an element that does not belong to set A or in set B, they belong still to the universal set, and then they are placed in region 4. So this concludes part 1 of chapter 2.3. We will continue our discussion of more details about sets and Venn diagrams in Part 2 of Chapter 2.3.